Hi students, today we will discuss one of the important chapter in the 12th class, that nothing but these solutions. So one by one, like what is the solution, different types of solutions, okay, what is the concentration terms, next what will be the colligative property. So all these things we will discuss one by one. So first I will go with the solution, okay. Solution. So yes, can you please define solution, anyone? Right, so let us see. So homogeneous mixture of the two or more components in certain limits, okay. So here must be homogeneous mixture. So homogeneous mixture of the two or more components. So what is the meaning of homogeneous mixture? Homogeneous mixture means, so throughout the mixture it should be has the same composition. That is called which one? Homogeneous mixture. Simply we can say homogeneous mixture of homogeneous mixture of two or more components, two or more components in certain limits, in certain limits, called as what? Called as solution. Right, so what is the meaning of homogeneous mixture? Homogeneous mixture, as I told you, so throughout the mixture it should be has the same composition, okay. That is we can say to be homogeneous mixture, okay. So same composition, same composition throughout the mixture, throughout the mixture. That is said to which one? Homogeneous mixture, okay. Right, so homogeneous mixture of the two or more components in certain limits we can say to be solution, okay. So generally we can say solution is made up of the two components, okay. So solution is made up of two components. Here what is that one? So solute plus solvent, that is we can say to which one? Solution, okay. So by mixing of the solute to the solvent, then we can get which one? Solution will be getting, okay. Generally solute will be the in the less composition it is there, and solvent will be the more composition it is there here, okay. Right, so this is the solution. And we can say here always um, physical state of the solvent that will be decided, that will decides the physical state of the solution. Simply we can say solution physical state, it is always depends on the physical state of the solvent only, okay. So we can say same thing here. So physical state of solution is always equals to which one, ma? Is always equals to so physical state of solvent, okay. Right, so for example you can take one some 100 ml of the water you can take, in that you can mix some amount of the sugar, okay. And if the sugar dissolves completely in that water, so what we can say there? That will be in the liquid state only. That means here solvent is water, solute is the sugar, so solution will be present in the liquid state, okay. Right, so now we will go with the classification of solution. So classification of solution, okay. Right, so based on the different cases we can say to be different classifications are there here. So first one we will go with the, I'll go with them based on number of solutes, based on number of solutes. Right, so based on number of solutes there is a different types of the solvents are there, and we can say here generally uh, three different types we can say here, which is the binary solution, binary solution. Next one we can say to be ternary solution, ternary solution, and one more we can say to be quaternary solution, quaternary solution. These things. Okay, so what is the binary solution? Simply we can say in case of the binary solution, one solute and one solvent only present here. So that means only one solute it is there, always solvent will be one only, one solute plus one solvent if it is there. Those we can say to which one? Binary solution. Can you please give an example? So you can say here example is generally sugar and water you can take, sugar plus water, or one more it is well known example, alcohol plus water. These are some examples for this one. And come to the next one, ternary solution. What is ternary solution? We can say to be one solute, sorry, two solutes plus one solvent if it is there, that we can say to be simply ternary solution. Example for this one, we can say to be, I can say sugar plus NaCl. So salt also I am adding along with the water. So this one I can say to be ternary solution. Okay, right. Next one I will go with the quaternary solution. Quaternary solution means here it is the three solutes, three solutes plus one solvent. This is nothing but the quaternary solution. So can you please give one example? Any one example here? So I will take the one other thing like a sugar, or you can take sugar, NaCl, and honey also I am taking. Honey with the water I am taking, and this is the three solutes and one solvent it is. And this is we can say to be simply a quaternary solution here. Okay, so these are the different types of the solutions based on the number of solutes. Okay, right. So another classification it is there, we can say to be based on the physical state of solution, we can say to be different classification it is there here, and we will see here types of solution based on types of solution based on physical state of solution, physical state of solution, right. So the three physical states generally possible: solid solutions, liquid solutions, next one gaseous solutions. So we will see what is the three different types of the solutions based on the physical state. So as I told you, so there is a three possibilities are there. What is three possibilities, students, here? One is the liquid solutions, liquid solution. One more it is what? Gaseous solution. One more we can say to be solid solution. Solid solution. Let us see what is the difference between all these three based on the physical state. Let us see first thing I am taking as a physical state of or type of solution I am taking. Type of solution. Next one, physical state of solute. Physical state of other one is physical state of solvent. Other one I will take as the other column, like example you can take example. Okay, right. Let us go with the first one, type of solution. So liquid solution you can take first. liquid solution. Okay, right. So in case of the liquid solution, so physical state of solute, the three possibilities are there, but solvent will be always liquid only. So here I am taking as a liquid, liquid. One more, it is solid and liquid. Next one, gas and liquid. So liquid type of solution, simply we can say uh, alcohol and water you can take. So C2H5OH and H2O as a example for this one. Next one, solid liquid type of solution, that nothing but the NaCl plus water or glucose plus water. These are the some examples for the solid in liquid type of solution. Next one, gas in liquid type of solution, that we can simply set as an example soda water we can take. Soda water. This is an example for the gas and liquid type of solution. These are the different possibilities in the case of the liquid solution. Okay, right. So come to the next one. That nothing but the I am taking like a gaseous solution. You can take gaseous solution. In the case of the gaseous solution, here also three possibilities, which is the so gas in gas type of solution. Next one, liquid in gas type of solution. One more, it is solid in gas type of solution. And come to the first case example, gas in gas type. Simply we can say mixture of gases. So mixture of gases we can say to which one? Example of the gaseous solution, gas in gas type of solution. Okay, mixture of gases. Why? Because in the if you take one sample of the gas, so the composition of the gases will be the whatever the condition you can take. This is the remain same only. Generally, I am saying not in the industrial areas those cases. Okay, right. So come to the case. Another other one is like a liquid liquids in gas type of solution. Simply I can take as a moisture. You can take example here. Moisture, which means water present in the gas. Okay, right. Another one, solid in gas type of solution, simply we can say like a sublimable solids in the gas, like iodine in the gas or naphthalene in gas, camphor in gas. So all these are example we can say in the case of which one, gaseous solutions. And we can say one more example, ammonium chloride also we can take here. So generally iodine in water, sorry, iodine in gas, iodine in air, iodine in air. Next one, ammonium chloride in air, naphthalene in air, naphthalene in air. So these are the examples in the case of like a solid in gas type of solutions. Okay, and come to the other case, other example like a other type of solution, which is solid solutions. Solid solution. Here are also three possibilities here, which is the solid in solid type of solution. Next one, gas in solid type of solution. Next one, liquid in solid type of solution. So these three, let us see what is the examples in these three particular cases here. First two case we will say here, solid in solid type of solution. Alloys. Alloy means what? Alloy means generally homogeneous mixture of the two or more metals. So that we can say to be alloy. Alloys. So generally we can say normally which we are wearing ornaments. So ornaments are prepared by the not 100% gold. So it is a mixture of some copper also. Okay, this is the one of the example for the solid in solid type of solution. Next one, gas in solid type. Simply we can say um, gas is absorbed over the some metals. Okay, in that condition we can set as an example for this one. So gas is absorbed on surface of metal. Gas is absorbed on surface of metal. Surface of metal. This is the one example for this one. Next one, liquid in solid type solutions. We can set to be amalgams. Amalgam, simply we can say, how can you define amalgam? So in mercury in metals. Metal combination with the mercury, we can set to be amalgam. Okay, so amalgams are the example for the liquid in solid type of solutions. Okay, these are the different types of the solution based on which one physical state of the solution. Okay, right. Next one, we'll go with the concentration terms. Before entering into the concentration terms, so what do you mean of the concentration? Okay, so concentration we will express in terms of the uh, in terms of some terms are there. Okay, like a weight percentage, volume percentage, weight by volume percentage, these things, these are the different terms which is express the concentration. Okay, right. We can say what is the concentration. So amount of solute present in the solution is expressed in terms of what? Concentration. Yes, let us take same definition. Amount of solute present in solution is expressed in terms of concentration. In terms of concentration. So amount of solute present in the solution is expressed in terms of what? Concentration. So to express this concentration, there is a different terms are there here. Let us see what is the concentration terms. Concentration terms, right? So one by one, if you see concentration terms, like a weight to weight percent. Second thing, we can say volume to volume percent. And third one, weight to volume percent. Next one, mole fraction. And another one, molality. Another molarity. There are two different type of the words, this one, molarity and molality. Next one, normality. Next one, ppm. So simply parts per million. These are the different types of the concentration terms. So we will discuss one by one what is the concentration terms here. Okay, right. First we will go with weight by weight percent. That means weight in weight. That means what here? Simply we can say weight of solute present in the weight of solution. That is simply we can say weight percent. So we can take the definition: amount of solute present in grams. amount of solute present in grams, present in grams, present, simply we can say solute in grams, amount of solute in grams present in 100 gram of solution. There simply we can set as a weight percentage. So let us see weight percentage in terms of the formula. How can you write here? So weight of solute divided with weight of solution into 100. Okay, so since we are expressing in terms of the percentage, so we can multiply with 100 here. This is the weight percent. Okay, right. So here weight of solution we are writing. Weight of solution means weight of solute plus solvent. So we can say here weight by weight percent that equal to the weight of solute divided with weight of solvent plus weight of solute into 100. Okay, this is the other expression for the this weight percentage. Okay, and we know one more expression we can write for this one. Weight of solution means simply we can say, so we know density of solution, that nothing but what? Density is equals to the weight by volume. Now weight is equals to the density into volume we can write here, which means what? Weight of solution that equal to density of solution, into volume of solution. You can take volume of solution. Okay, right. This is the other expression for the weight percent. So weight to weight percent we can write here, which is the weight of solute divided with density of solution into volume of solution into 100. Okay, right. So these are the different terms, different expressions for the weight percent. Okay, right. So about questions we will discuss later. About this one, questions we will discuss later. Now we will go with the next concentration term, that nothing but the volume percent. So what is the volume percent? Simply we can define. So volume of solute present in the volume of solution. Simply we can say volume of solute in milliliters, in ml, present in the 100 ml of the solution is the volume percent. Okay, you can take same thing. Volume of solute in ml present in 100 ml of solution. Okay, this is the volume percent, right? So let us write the, in terms of mathematically how you can write volume percent that equal to the volume of solute in ml only, in milliliters, divided with volume of solution into 100, right? So here volume of solution means, as like we have discussed here, weight of solution is equals to the weight of solvent plus weight of solute. Similarly, here also weight of solution is equals to the the volume of solution equal to the volume of solution. Simply that equal to the volume of solute plus volume of solvent. Right, we can take same thing. So volume percent that equal to the volume of solute divided with volume of solute plus volume of solvent into 100. This is the different terms to express the volume percent. Okay, right. So this is what about the volume percent. Let us go with the another concentration term, that nothing but weight to volume percent. Weight to volume percent, that means weight in volume. Simply we can say, so weight in grams present in the volume of solution. Okay, right, you can define simply here, amount of solute in grams, amount of solute in grams present in 100 ml of solution. This is the weight to volume percent. Simply we can say weight by volume percent, that equal to the weight of solute divided with volume of solution into 100. This is the weight to volume percent. So generally we can say solid in liquid type of solutions we will express in terms of the this concentration term. Okay, so solid in liquid type of solutions generally we will express in terms of the this type of concentration term. Okay, right. So let us go with the next concentration term. That's nothing but the mole fraction. So what is the mole fraction? So as the name it is given that it is the fraction of moles, mole fraction. So as the name it is given that nothing but it is the fraction of moles, fraction of moles. Okay, now how can you define this mole fraction? Simply we can define this one. So the ratio between number of moles of one component to total number of moles. So in a solution there is a different components are there, as we discussed, solute and solvents are there. So here it is the ratio between number of moles of one component to total number of moles, that is the mole fraction. Okay, simply we can define this one. It is defined as number of moles of one component to defined the ratio between number of moles of one component to total number of moles. Right, so this is the mole fraction. So let us see here, for example, like in your solution there is a solution is made up of the three components I am taking. So a solution is made up of the assume a solution is made up of so three components. Three components A, B and C you can take. So A, B, C, three components are there here. So with respect to these A, B, C components, so let us see what is the weight and molecular weight, number of moles, all these three. Right. First let us go with the weight. So weight of the solute I am taking as a W, I am taking WA, and weight of the B is, weight of the A is WA, weight of the B is WB, weight of C is WC. Molecular weight of the A is the MA, molecular weight of B is MB, molecular weight of C is MC. Now tell me what is the number of moles? What is the formula for number of moles, students? So number of moles is weight of the component, weight of compound by divided with molecular weight of compound. Molecular weight of compound. This is the one of the expression to express the number of moles. Right. So same way here, number of moles is I am taking Na. Na is equals to the Wa by Ma. What is the number of moles of B? Which is Nb, that is equals to the Wb by Mb. What is the number of moles of C? Which is Wc by MC. So these are the number of moles of the each component present in the solution. Okay. Now what is the mole fraction of the mole fraction with respect to A, mole fraction with respect to B, mole fraction with respect to C? Right. So let us see mole fraction of A. First one, mole fraction of A, which we can set to be chi. This is the chi M. So like a, it looks like a X only. Mole fraction of A. So according to definition, it is what? Ratio between number of moles of one component to total number of moles. Now I am discussing mole fraction of the A, which means number of moles of, ratio between number of moles of A to total number of moles is the mole fraction of A, which is, I can say to be number of moles of A is Na divided with Na plus Nb plus Nc. This is the mole fraction of the A. And similarly, what is the mole fraction of the B? So you can say to be chi B. What is the mole fraction of the B? Nb divided with Na plus Nb plus Nc. And similarly, what is the mole fraction of the C? Which we can say chi C. Nc divided with Na plus Nb plus Nc. So this is the mole fraction expression for the three components present in the solution. So this is, it looks like a X, so this, but it is called as chi A, but we will call XA, XB, XC, no issue. Right. So these are the expressions for the mole fraction of the different components in the solution. Okay. Right. This is the three components are present in solution, which we can consider as a ternary solution. Okay. But I am taking as a binary solution. What is the binary solution? As we discussed in the earlier, binary solution. Binary solution means only one solute and one solvent is present. We can say to be binary solutions. So in case of the binary solutions, in case of binary solutions, right. So we can say here, what is the mole fraction of the A? Mole fraction of the A is, So number of moles of A divided with number of moles of A plus number of moles of B. That means only two components I am taking here, which is the made up of the A and B components. So what is the mole fraction of the B here? So number of moles of B to the ratio between number of moles of B to number of moles of A plus number of moles of B. Okay. So this is the mole fraction, this one. So if it is a binary, in case of the binary solution, simply we can say, so xa plus xb is equals to the 1, we can say here. Okay. Xa plus xb is equals to what here? Is equals to 1, which is the mole fraction of the A and mole fraction of the B is equals to 1 in case of the binary solutions only, not in the case of the ternary solutions. Okay, right. So what is the mole fraction of the A? If you know the one component mole fraction, other component mole fraction we can easily find here, which is the XA is equals to the 1 minus XB, we can write, and XB is equals to the 1 minus XA, we can write. This is the mole fraction of the two components here. Okay, if you know one component mole fraction, other component mole fraction we can able to find in the case of the binary solutions. Okay, only in the case of binary solutions, right? This is the about some concentration terms, right? So now we will discuss what is the questions possible about these four concentration terms. So one by one questions we will discuss here. Okay, right, let us take the first question. Right, so 6 grams of, take the question. So 6 gram of urea dissolved in 100 gram of water. 100 gram of water. What is weight percent? What is weight percent? Weight by weight percent. Right. Yes, 6 gram of urea dissolved in the 100 gram of water. What is the weight percent is asking question. Right. If you see the formula for the weight percent, that nothing but the weight of solute divided with weight of solution. Weight of solution into 100. This is the weight percentage formula. So here 6 gram of the urea dissolved in 100 gram of water. Here water is solvent only. Okay, that means what? Solution is made up of the solvent plus solute. That means when you consider as a solution means these both, you have these both weight you should consider here. Okay, which means weight percentage equals to the, so weight of solute, how much it is? 6 grams divided with weight of solution is equals to the 100 plus 6 into 100. Why? Because solution is made up of the solvent plus solute both. Okay, right. So what is the answer, students? So 6 divided with 106 into 100. So this will be the, we can say to be 1.6 divided with 1.06, which is the almost, so 5.6% will be getting weight percent. Right. Next question. Next question, we can take 34.2 gram of glucose C6H12O6 present in 400 gram of water. 400 gram of so what is the percentage by mass of solution? Percentage by mass of solution. So percentage by mass or weight percent, what are the same things only. Like you can say definition same. I mean, what is the formula here? Weight by weight percent, that is equals to the weight of solute divided with weight of solution into 100, right? Similar like a previous question. So weight of solute is it is given 34.2 grams divided with, so 34.2 plus 400 into 100, right? So this is becomes 34.2 divided with 434.2 into 100. This is becomes the 4.342. Now weight percentage equals to 34.2 divided with 4.342, which will be coming 7.3, 7.8 will come almost, right? This is the next question. And another possible question here, which is 40% by mass of solution is obtained (190 gram of urea dissolved in 400 ml of solution. Okay, right? So calculate density of solution. Right, so look at here students, there is given percentage by weight is given, and weight of solute also given, and volume of solution also given, and asked about density of solution. Okay, right? So we also know the formula here. So weight by weight percentage equals to the, what is the percentage by weight formula? Percentage by mass, percentage by weight, both are same only, right? So what is the formula? Right, we know the formula, weight of solute divided with weight of solution into 100. So weight of solution is equals to what? Density of solution into volume of solution. Okay, now weight by weight percent we can write like a weight of solute divided with density of solution into volume of solution into 100. Okay, right? Let us see, weight percent is given 40% here, 40, that equal to weight of solute given 190 grams divided with density of solution we need to find, volume of solution is the 400 ml is given into 100. Now let us solve this question, right? We can write 40 into 400, that equal to the 19000, right? So 40D into 16000, that equal to the 19000. Now density, after some calculations here, density we can write 1.12 gram per ml. This is the answer will come after calculating density here. Okay, right? Next question you can take. Let us see next question. 23 gram of C2H5OH present in 54 gram of water. Calculate mole fraction of water and mole fraction of C2H5OH in the solution. Right. So this question is according to, I mean, we should calculate here mole fractions of the components we should find here. Okay, right. So for that we need to know about the number of moles of C2H5OH, which is ethyl alcohol, and number of moles of water also we should find first. Right. What is the molecular weight of C2H5OH? Molecular weight of C2H5OH. Ethyl alcohol, that nothing but the 46. Other one is molecular weight of water. How much it will be? 18. Now what is number of moles of water? Number of moles of ethyl alcohol, that equal to the 23 by 46, which is the 0.5. Here number of moles of water, that nothing but 54 by 18, which means 3 moles. Now what is the mole fraction? Mole fraction of ethyl alcohol. Mole fraction ethyl alcohol, that nothing but what? So C2H5OH. Mole fraction of ethyl alcohol is the number of moles of ethyl alcohol to total number of moles. Number of moles of ethyl alcohol is the 0.5. Total number of moles is 0.5 plus 3. So we can say here 3.5. Right. If you find this one, other one you can easily find easily. Okay. So what will this one answer? 0.5 divided with the 3.5. So you will be getting 0.15. This is the number. This is the mole fraction of the ethyl alcohol. If this mole fraction is the 0.15, since it is the binary solution, we can set to be mole fraction of the water is equal to what? Mole fraction of water, that is equal to the 1 minus mole fraction of ethyl alcohol. Okay, and which will be coming, so 1 minus 0.15, so 0.85 will come. Or if you calculate the same here, you will be getting same answer. So XH2O, that equal to the 3 divided with the 3.5, which will become same answer only, 0.85 only will come. Okay, so in case of the binary solutions, one mole fraction we can find, other mole fraction so easily we can get. Okay, right. So another question we will see here, another possible way how to ask the question here. Find the mole fraction of HCl. Find the mole fraction of HCl containing 24.8% by mass of HCl solution. Right. So here we should find the mole fraction of HCl containing 24.8% by mass of the HCl solution is asking. So that means what? In 100, so 24.8% by mass of HCl solution, which means what? 24.8% by mass of HCl solution means what? Means in 100 gram of solution, 24.8 gram of HCl present. This is the meaning of this. Okay, right. Now what is the mole fraction of HCl here? For that we should find the number of moles of HCl, and remaining is what here? Out of 100 grams, 24.8 grams is HCl, remaining weight is the water only. Okay, right. So what is the weight of water here? Weight of water, we can say 100 minus 24.8, which means the 75.2 grams, right? This is the weight of water. Now let us take here number of moles of HCl. Number of moles of HCl. What is the molecular weight of HCl, student? Which is 36.5. Okay, so weight is what? 24.8 divided with 36.5. What is the number of moles of water? Right, so 75.2 divided with 18 grams. This is the molecular weight of water. Now what is the number of moles? Number of moles will come almost 0.13 moles. Here number of moles is this number of moles we can say 0.67. Right, this number of moles we can say almost 4 point something, so 4.17 moles will come here. Now what is the total what is the mole fraction of HCl here? So mole fraction of HCl, that nothing but the 0.67 divided with, so 4.17 plus 0.67, so it will be coming 4.87. okay, right, 4.87. so if you calculate this value, right, this will be coming 0.13. so this is the mole fraction of HCl. If this is mole fraction of HCl, what is the mole fraction of water? Which means 1 minus 0.13, so it will come 0.87 will come as a mole fraction of water, right? So this is what about the some questions related with these 4 concentration terms. Okay, right. So in the next class we will discuss about remaining 4 concentration terms which are left, like a molality is left, molarity, next one normality, next one parts per million. So these concentration terms will be discussed in the next class. Okay, right. So thank you, students. Thanks for watching video. So if you want any concepts, so please comment below. We will discuss those topics.